Hello everyone, we are now on a new chapter, reactions of benzenes and substituted benzenes. Many substituted benzenes are found in nature. A few that have physiological activity are shown here. Some of the great examples are adrenaline, which is also called as epinephrine, a hormone that is released by the body in times of stress, and ephedrine, which is a bronchodilator, and chloramphenicol, which is an antibiotic that is used for typhoid fever. And apart from this, there are also many other physiologically active substituted benzenes that are not found in nature but are synthesized by man. Great examples are Lexapro, which is an antidepressant, Plavix, an inhibitor of platelet aggregation, and Zytec, as you guys all know, that is an antihistamine. Chemists have also synthesized compounds with structures similar to the naturally occurring physiologically active compounds. Here you see two different structures. One is amphetamine, and the other one is methamphetamine. Methamphetamine is also called as speed. These two are central nervous system stimulants, which are whose structures are very close to the structure of adrenaline, which is also a central nervous system stimulant. Okay, let's go on to the nomenclature. The nomenclature of simple benzenes are going to be like really easy. You add the name of the substituent to the benzene. That's it. So as you can see here, you have a bromine on benzene, so it's actually bromobenzene. A chlorine on a benzene is going to be chlorobenzene. As long as you have only one substituent, it's just going to be you're just going to add the name of the substituent in front of benzene. This is a nitro group, so it's nitrobenzene. This is an alkyl group, and to be more specific, it's an ethyl group, so it's an ethylbenzene. But some monosubstituted benzenes have names that incorporate the substituent. These need to be memorized. Okay, so here are some examples for it. So these obviously needed to be memorized. Okay, so phenol has an OH on a benzene group. Aniline has an NH2 on benzene ring, and toluene has a methyl group on a benzene ring. A benzene sulfonic acid is got by putting a sulfonic acid group. This is the sulfonic acid group on the benzene ring, and if you have a OCH3, then it's actually called as anisole, which is an ether. And benzaldehyde, when you have a carbaldehyde group on benzene, it's actually benzaldehyde. When you have a carboxylic acid group on benzene, it's actually called as benzoic acid. And styrene is basically used in synthesizing many of the polymers. And when you put a nitrile group on benzene, it's actually called as benzonitrile. Okay, this is something very important. What's the difference between a phenyl and a benzyl group? Okay, a phenyl group is actually going to just have a benzene ring in it. Okay, so where benzene ring is going to be a substituent, whereas a benzyl group is going to have an adjacent methylene group on the benzene ring. Okay, so here we have some compounds which has phenyl rings and benzyl group on it. Let's see how we can find the name for these compounds. So this compound right here is benzyl chloride, because you can see that there is an adjacent methylene group that is attached to the benzene ring. Okay, this structure right here is actually diphenyl ether, because you don't see the methylene group on it. It's diphenyl ether. Diphenyl ether. And this structure, because you have the benzyl group on either side of it, and these two benzyl group are connected by oxygen, therefore it's a dibenzyl ether. I hope it's clear. Now let's go on to the alkyl substituted benzenes. Okay, with an exception for toluene, all of the alkyl substituted benzenes are going to be given the name. Like the parent name is going to be benzene, and you're going to put the alkyl in front of the benzene. Okay, so if you take this one, This group right here is actually isopropyl group. So it's going to be called as isopropyl benzene. And this group is actually secondary butyl benzene, secondary butyl group, and therefore it is a secondary butyl benzene. And this is a tertiary butyl group, and therefore tertiary butyl benzene. And for naming this compound right here, you cannot call this as secondary pentyl benzene. Instead, you're going to call this as 2-phenylpentane, taking into consideration that this is your parent name and your phenyl ring is actually a substituent on the alkane. And similarly here, your phenyl ring is existing as a substituent on the third carbon in the alkane. Okay, so if you take this as your parent name, this is going to be pentane, and your phenyl ring is present on the third carbon, so it's actually 3-phenylpentane. Okay, aryl substituted benzenes. So what are aryl substituted benzenes? So say for example, if you in general, the aryl substituted benzenes are represented by AR, okay, just as you have R for any general alkyl group. And here is a great example for it. If you have an OH present on a benzene ring, it's actually called as phenol, right? So a good representation for phenol is going to be ArOH, meaning that you have an OH on the benzene ring. Okay, now reactivity of benzene. How does the benzene react? Okay. Benzene can undergo electrophilic aromatic substitution. Electrophile is going to substitute for one of the hydrogens that is present in the ring. So this is your benzene ring, and you know that there are total of 6 hydrogens in it. One of the hydrogens is going to get replaced for the electrophile. Okay, so as you can see, the hydrogen in this position was replaced for an electrophile. But how does this occur? So if you look into the mechanism, if you look into the structure of benzene, we know that the benzene has 3 pi electrons. Okay, so here are the 3 pi electrons. Okay, and we know that the pi electron is going to have 2 lobes. Okay, and the electrophilic aromatic substitution reaction, the first step of the electrophilic aromatic substitution is going to be similar to that of the electrophilic addition reaction of an alkene. Okay, so the first reaction here is going to be, the first step is going to be these electrons right here is going to go attack the electrophile, thereby forming a carbocation. Remember, the first step in the electrophilic addition of alkene is the formation of the carbocation, right? So it's going to form a carbocation here. Okay, so this is the carbocation intermediate that is formed. Okay, now what is the next step? Okay, let's just recall what has happened in alkene electrophilic addition reaction. Okay, so let's do the alkene mechanism for the electrophilic addition reaction of alkene. Okay, so basically these electrons are going to go and attack the electrophile, and you will form a carbocation. So here, because the structure is symmetrical, you don't have to be worried about what type of carbocation is formed. But in general, the most stable carbocation is going to be formed depending upon the substituents on the carbon. Okay, and then when it is going to react with the nucleophile will go and attack the carbon, which is electropositive. Okay, and this would be the product that will be obtained. Okay, so here basically the electrophile is getting added in the first step, okay, and the nucleophile is getting added in the second step. So basically the reaction of the alkene, the main reaction that the alkene would undergo is the electrophilic addition reaction. It is the electrophilic addition reaction. But in the case of benzene, let's see what's going to happen in the next step. Okay, so after benzene acts as a nucleophile, okay, so benzene is acting as a nucleophile, attacking the electrophile, and it's going to form the carbocation. Okay, once that carbocation is formed, if the Z minus goes and attacks the electrophilic carbon, then it's actually going to form a non-aromatic compound. Okay, so you can see that the aromaticity is destroyed and it's going to form the non-aromatic compound. But usually usually when you take a reaction, stable compound, formation of this stable compound is preferable. Okay, but if the reaction goes in another way, where this nucleophile goes and abstract a hydrogen which is present on the same carbon as the electrophile, then it's going to form a aromatic compound. So let's see how that happens. Again, it's going to form the carbocation. So instead of this Z going and attacking this carbon, if it goes and abstracts this hydrogen right here, okay, so if the Z goes and abstracts this hydrogen, then it's going to push the electrons back in again, forming the double bond, thereby restoring the aromaticity of the molecule. Okay, so this compound right here is aromatic. So this is the reaction that is basically formed by benzene and its derivatives. Okay, so the type of reaction that the benzene undergo would be electrophilic aromatic substitution. And why substitution? Because the hydrogen is replaced for the electrophile. Okay, so the hydrogen right here is replaced for an electrophile.